and electron configuration. This is found in your book. These are the objectives for this lesson. First is to describe the quantum mechanical model of an atom. Second is to describe the location and energy of an electron using quantum numbers and write the electron configuration of an atom using the concepts of shells, subshells, and orbitals. So we have the four quantum numbers. We have the n, the l, the m sub l, then the m sub s. The first quantum number is the principal quantum number, symbolized as n. Its allowed values is any positive integer, meaning it can be 1, 2, 3, 1, 2, 3, 4, and so on. So this quantum number describes the distance of the electron from the nucleus. So for example, when n is equal to 1, that's the closest electron from the nucleus. And then as we go away from the nucleus, the value of n becomes larger and larger. And aside from the distance, this also describes the energy of the electron. So as we go away from the nucleus, the energy goes higher and higher. So we also call this one as energy levels because again, these levels also have different energy. That's the first quantum number, the principal quantum number. The next quantum number is the angular momentum quantum number. It's symbolized as L. Its value depends on the value of n. So its allowed value is any integer from 0 to n minus 1. It describes the shape of the orbitals. So for example, for the first energy level, the n is equal to 1. So if n is equal to 1, what are the allowed values for L?
0.
0, sir.
Right, that's 0. So on this case, of course, n minus 1 is 0. So on this case, there's only one allowed values for L when n is equal to 1. So this L is also the sublevel. So here, the n represents the main energy level. The L represents the S sublevel. So for the first energy level, there's only one sublevel, and that's when L is equal to 0. Let's go to n if is equal to 2. So this is the second energy level. If n is equal to 2, what are the allowed values for L?
1.
Again, it starts from 0, so 0 and then. Is there any other allowed value?
0 and 1.
Right.
1, sir.
Okay, off sound mic. Okay, so when n is equal to 2, we can have two possible value for L. So that's L is equal to 0 to L is equal to 1. So on this case, on the second energy level, there are two sub-levels. That's the 0 and then the 1. Then let's go to n is equal to 3. This is the third main energy level. When n is equal to 3, what are the allowed values for L? It starts
0,
from
0, 1, sir.
0, 1, and then are these the only allowed values?
2, sir.
Okay, it can be 0, 1, and 2. So on the third energy level, we can have three sub-levels. We have the 0, 1, and 2. Let's go to the fourth energy level. That's n is equal to 4. What are the allowed values for L?
0, 1, 2, 3.
Right, 0, 1, 2, 3. So on the fourth energy level, okay, off sound mic. On the fourth energy level, there are four sub-levels, 0, 1, 2, and 3. Okay, so these are the sub-levels. And by the way, we have a nickname for each sub-level. When L is equal to 0, we call that one as an s orbital. Okay, this one is an s orbital. When L is 1, that is a p orbital. And when L is equal to 2, that's a d orbital. And then when L is equal to 3, that's an f orbital. So These are the four main sublevels. We have the S, P, D, F. This quantum number describes the shape of the orbitals. So these are the different shapes. So when L is equal to 0, we are referring to an S orbital. It's ball shape na orbital. Next, when L is equal to 1, we are referring to a p orbital. So it's a dumbbell shape orbital. And next, when we have L is equal to 2, that's a d orbital. So as we go to a higher number of L, we get more complex shapes. And then when L is equal to 3, we are referring to an f orbital. So again, this quantum number describes the shape of the orbitals. That's the second quantum number. Again, the value of L depends on the value of n, which is the principal quantum number. The next quantum number describes the orientation of the orbital. The value of m sub L, or the magnetic quantum number, depends on the value of L. So for example, let's say when L is equal to 0, what are the allowed values for m sub L?
-1 and 1.
No, it's 0 on L. So in this case, it's just 0 because our L is 0. When L is equal to 1, what are the allowed values for m sub L?
-101.
Negative
1, 0,
1,
+1.
and then positive 1. When L is equal to 2, what are the allowed values for m sub L? Negative what?
-2, -1, 0, 1, and 2.
Okay, so we have -2, -1, 0, +1, and +2. When L is equal to 3, what are the allowed values for m sub L?
-3, -2, -1, 0, 1, 2, 3.
1, 2, and then 3. Okay, so let's go back to the, again, when L is equal to 0, we are referring to an s orbital. Okay, this is an s orbital. When L is equal to 1, that's a p orbital. When L is equal to 2, that's a d orbital. When L is 3, that's an f orbital. Okay, so as you see here, for S, we have one type of s orbital. There's 0 lang. Pag p, we have three types of p orbitals. We have -1, 0, and +1. When d, we have 1, 2, 3, 4, 5. 5 types of L orbital, and then for for F rather, we have 1, 2, 3, 4, 5, 6, 7 types of L orbitals. Let's see that one on the actual picture. So again, this quantum number describes the orientation of the orbital, or how the orbital is positioned. For example, for a p orbital, it can be oriented on the x-axis, or it can be oriented on the y-axis, or it can be oriented on the z-axis. So again, for a p orbital, that is when L is equal to 1. And again, when L is equal to 1, m sub L can be -1, 0, and then +1. So again, we have three types of L orbitals. Again, for S, we only have one type of S orbital. That's the 0. Right now, L is equal to 0. The m sub L is 0. When L is equal to 1, what are the possible value for m sub L? M sub L can be
-1, 0, and 1.
okay, we have -1, 0, and +1. So here we have three types of p orbital. When L is equal to 2, what are the allowed values for m sub L?
-2, -1, 0, 1, 2.
Okay, 0, +1, and +2. So we have here 5 types of d orbitals. When L is equal to 3, what are the allowed values for M sub L?
-3, -2, -1, 0, 1, 2, 3.
Again, correct. That's -3, -2, -1, 0, +1, +2, and then +3. So again, for S, we have 1 type of S orbital. For P, we have 3 types of P orbital. For D, we have 5 types. Then for F, we have 7 types of F orbitals. The last quantum number, it's not related to the address of the electron, but this is an important property of an electron. This is the spin quantum number, symbolized as M sub L. Its allowed values can only be -1/2 or +1/2. This describes the spin of the electron. So an electron can either have a down spin, -1/2, or an up spin that's +1/2. Now let's know the address of the electron inside an atom. These are the different principles we need to take in mind while assigning the electrons on each of their location in the nucleus. The first is the Aufbau principle. According to this principle, the first electrons will occupy the lowest energy level before the higher energy level. The energy depends on the principle and then the L quantum number. Next, no two electrons can have the same set of quantum numbers. Let's have lithium. Okay, so let's do the electron configuration of lithium. First, how many electrons is present in a lithium atom? How many electrons?
3, sir.
Okay, we have 3 electrons. Now, where can we find these 3 electrons? Okay, for a while.
Nasa ubos, sir?
Right, so we have 1, 2, and then 3. So this is a guide, by the way. So this is what we did kanina. So for the first energy level, we have 1 sublevel, that's the S sublevel. For the second energy level, we have 2 sublevels, the S and then the P sublevels. The third energy level is composed of 3 sublevels. We have the S, the P, and then the D sublevel. For the fourth sublevel, we have 4 sublevels. We have the S, the P, D, and then the F sublevels. So again, these are the possible locations of the electrons. So lithium has 3 electrons. Where can we find the first electron? Is it on the 7th energy level, the 4th, the 2nd, or the 1st energy level?
First po, sir.
Right. Again, according to the Aufbau principle, the first electrons will occupy the lowest energy level. And again, that's the first energy level. On the first energy level, there is 1 sublevel, that's the S sublevels. Okay, so here, according to the Pauli's exclusion principle, no 2 electrons can have the same set of quantum numbers. Okay, so let's say this first electron will occupy the first energy level on the S sublevel. So here we have a 1 electron. What about the second electron? Where can we find the second electron?
Sa first gihapon, sir.
Okay, it's still on the first orbital. Pero diba, according here, no 2 electrons can have the same set of quantum numbers. If they occupy the same energy level and the same sublevel, how can they have different set of quantum numbers? What quantum number is different on these 2 electrons? Obviously, on this case, they have the same value of N and the same value of L and the same value of M sub L. So what's the difference between these 2 electrons? Kasi based on the exclusion principle, no two electrons can have the same set of quantum numbers.
Kuan siya, sir, up, down.
Right, so in this case, we have these two electrons have different spin. Maybe this first electron have an up spin, then this second electron has a down spin. So in this case, in every orbital, there are two possible electrons that can occupy, because again, we have two different values for spin. One can either spin up and the other can either spin down. Okay, so that's correct. Again, we have three electrons. The first electron on the 1s and the second is on the 1s pa rin. What about the third electron? Where can we find the third electron?
Sa second na, sir.
Okay, on this case, this is now full because only two electrons can fit on the s sublevel. So this now will occupy the next higher energy level. On the second energy level, we have two sublevels, the s and then the p sublevel. Where should we occupy first, the s or the p sublevel?
The S.
Right, so in this case, the s sublevel, because the s sublevel have lower energy compared to the p sublevel. So we have this third will occupy the 2s. Let's write this one. 1s, we have two electrons on the 1s. Then after 1s, we have the 2s. And then we have one electron over here. This is the electron configuration for lithium, 1s2, 2s1. So this superscripts are the electrons, and then these numbers here are the address of that electron. It means there are two electrons on the first energy level on the s sublevel, and on the second energy level on the s sublevel, we have one electron. So this is the electron configuration for lithium. Next, for boron. How many electrons are in a boron atom?
5, sir.
Right, we have 5. Where did you get that 5, by the way?
Sa atomic number.
So again, as we go back to our lessons before, the atomic number is equal to the number of protons, and the number of protons is equal to the number of electrons. 1, 2, 3, 4, 5. We have 5 electrons. Again, we have the first electron. Where can we find this first electron?
Sa first sublevel.
Okay, so first. What about the next one? Over here.
Second sublevel. Sa 2S.
Okay, now we have 2 here in this 2s. Where should the next electron go?
Sa 2P, sir.
Right, 2p. So here we only have 5 electrons. So I think we are good now. Let's write the electron configuration. 1s, 2, 2s2, then 2p, 1. That's the electron configuration for boron. So just check the superscript. The superscript must be equal to the number of electrons. We have 5 here and 2 plus 2 plus 1. That's the electron configuration for boron.